Hey everyone, and welcome back to the channel. When you hear Yellowstone, you probably think of geysers, bison, and maybe, just maybe, a supervolcano that could end the world as we know it. We've all seen the disaster movies, right? But what if I told you the story of Yellowstone's volcanic past is way more complex and, frankly, more interesting than just one big boom? Today we're digging deep into the Yellowstone eruptions you've probably never heard about. And trust me, it's a wild ride. First, let's get the big guys out of the way. The eruptions everyone talks about are the three massive caldera-forming events. The first one, the Huckleberry Ridge Tuff eruption, happened about 2.1 million years ago. This was the heavyweight champion, an absolutely colossal blast that was about 2,500 times bigger than the 1980 Mount St. Helens eruption. It created a massive crater, or caldera, and blanketed a huge portion of North America in ash. Then, about 1.3 million years ago, we had the Mesa Falls Tuff eruption. It was the smallest of the three super eruptions, but small is relative here. It was still big enough to be a global event. Finally, the one that shaped the park we know today, the Lava Creek Tuff eruption about 640,000 years ago. This is the eruption that formed the current Yellowstone caldera. Okay, so those are the big three. But here's where it gets really fascinating. The story doesn't stop there. In between these catastrophic super eruptions, Yellowstone wasn't just sleeping. It was very, very active. Think of a supervolcano not as a single mountain that blows its top, but as a massive, complex plumbing system of magma deep underground. This system is constantly shifting, heating, and releasing pressure. Between 1.3 million and 640,000 years ago, after the Mesa Falls eruption but before Lava Creek, Yellowstone experienced a period of what geologists call intra-caldera volcanism. This means there were numerous eruptions, but they happened inside the older caldera. These weren't super eruptions, but they were still enormous lava flows. Imagine this. Instead of one massive explosion, you have a series of giant fissures opening up in the ground, spewing out rivers of thick, slow-moving rhyolite lava. These flows were so immense they eventually filled up the entire Mesa Falls caldera, almost like filling a giant bathtub with molten rock. These are called the Yellowstone Plateau rhyolites. We're talking about dozens of individual lava flows, some of them covering hundreds of square miles and being hundreds of feet thick. They basically paved over the evidence of the older caldera. When you drive through Yellowstone today, much of the landscape you see, like the Pitchstone Plateau, is actually the top of these massive younger lava flows. So Yellowstone wasn't just quiet for 700,000 years, it was actively and relentlessly reshaping itself from within. Now let's jump to the time after the last big super eruption, the one 640,000 years ago. You might think, okay, it blew its top, now it's quiet. Nope. Not even close. Since that last major event, there have been at least 80, relatively non-explosive eruptions within the caldera. The most recent of these was just 70,000 years ago. That might sound like a long time, but in geological terms, it's the blink of an eye. These eruptions are similar to the ones that filled the older caldera. They are primarily massive lava flows. These flows are the reason for many of the features you see in Yellowstone National Park. They created the rolling hills and plateaus that make up the park's central basin. Why lava flows and not massive explosions? It's all about gas. The magma that fuels supereruptions is rich in dissolved gases like a vigorously shaken soda bottle. When it reaches the surface, that pressure is released, and boom. But the magma in these later flows had already released a lot of its gas, or degassed. So instead of exploding violently, it oozed out onto the surface, forming these thick, pasty lava flows. The west thumb of Yellowstone Lake, for example, is actually a smaller caldera that formed from an eruption after the big one, about 174,000 years ago. So what does this all mean for us today? Well, it paints a much more dynamic picture of Yellowstone. It's not just a binary switch of dormant or world-ending explosion. The most likely type of eruption for Yellowstone's future isn't another super eruption, but one of these hydrothermal explosions or a rhyolite lava flow, similar to the 80 that have happened since the last big one, A hydrothermal explosion is basically a geyser on steroids. Superheated water flashes to steam, creating a localized but still very powerful blast that can hurl rocks for miles. These happen every few thousand years. A lava flow would be much more significant. It would start with a series of intense earthquakes as the magma moves towards the surface. Then, a fissure would open, and lava would begin to pour out. It would be slow-moving, giving people plenty of time to evacuate, but it would be unstoppable, burying roads, buildings, and forests under hundreds of feet of rock. It would be a major, park-altering event that would last for months or even years, but it wouldn't be the global catastrophe we see in movies. Understanding this history is crucial. It shows us that Yellowstone has a whole range of behaviors. By studying these smaller, more frequent eruptions, scientists can better understand the magma plumbing system and get a clearer picture of what the volcano is doing right now. The constant ground uplift and subsidence, the earthquake swarms, the changes in geyser activity. It all fits into this pattern of a living, breathing, and constantly active volcanic system. So the next time you think about Yellowstone, don't just picture a single ticking time bomb. Picture a vast, complex, and ancient volcanic field that has been erupting in a variety of ways for over 2 million years. The real story isn't just about the 3 big bangs. It's about the hundreds of smaller events that have shaped one of the most incredible geological wonders on our planet. The odds of a supereruption happening in our lifetime are incredibly slim, but the certainty of Yellowstone remaining an active and fascinating place is 100%. Thanks so much for hanging out and exploring the hidden history of Yellowstone with me. If you enjoyed this deep dive and learned something new, do me a favor and hit that like button. And if you haven't already, subscribe and turn on notifications so you don't miss our next adventure. See you in the next video.